In today's session, we are going to discuss ionic equilibrium. New lesson. Today we will start. Today's lecture will be based on types of electrolyte, degree of dissociation, then types of acids and bases, and dissociation constant. Okay. Now last year already you have studied chemical equilibrium. This year you are going to study ionic equilibrium. Okay. Now the first point is types of electrolyte. Types of electrolyte. There are two types of electrolytes. Strong electrolyte and weak electrolyte. Okay. Now what is the meaning of strong electrolyte and what is the meaning of weak electrolyte? The electrolyte which dissociates completely is known as strong electrolyte. Weak electrolyte means the electrolyte which dissociates partially. See, the electrolyte which dissociates completely, it is strong electrolyte, and the electrolyte which dissociates partially means not completely, is known as weak electrolyte. Okay. Now examples of strong electrolyte. All the strong acids and bases. All the strong acids and bases and salts. Strong acids, strong bases and salts are the example of strong electrolyte. Why? Because when you add any strong acid into water, suppose this is the beaker containing water. Whenever you are adding any strong acid or strong base, strong acid like HCl, strong base like NaOH, it will dissociate completely. Means when HCl will dissociate, it will give two type of ions, that is H plus and Cl minus. NaOH will give Na plus and OH minus. Means it is going to dissociate completely. Means H and Cl will get, the bond between H and Cl will break completely, so it will get dissociated completely. Okay. This is about strong electrolyte. Salts. Whenever you are adding common salt, that is NaCl, which we use in kitchen. Whenever NaCl is added into water, it can dissociate completely. So it is strong electrolyte. Now, what is weak electrolyte? Weak electrolyte means the electrolyte which dissociates partially. Partially means not completely. Examples: instead of strong acids, you can take weak acids or weak bases and salts. Weak acids, weak bases, and some sorts of weak acid and weak bases. These are the examples of weak electrolyte. Okay. Now, the next point is degree of dissociation. What is meant by degree of dissociation? Degree of dissociation, in short, we can say how much of the percentage dissociation takes place. See, partially. Partially means not completely. Means only some of the part of that weak electrolyte gets dissociated. Exactly how much of the electrolyte, how much of the weak electrolyte is getting dissociated, that is the degree of dissociation. The degree of dissociation can be calculated by the formula degree of dissociation can be calculated by the formula number of moles dissociated, number of moles dissociated upon total number of moles taken. What is the formula? Degree of dissociation can be calculated by the formula number of moles dissociated upon total number of moles taken. How much of the moles you have taken, and out of that how many are dissociated. That ratio is nothing but the degree of dissociation. Degree of dissociation can be represented by symbol alpha. Degree of dissociation can be represented by the symbol alpha. Now, see, suppose we will make one table. Three columns. Suppose number of moles taken, number of moles taken, number of moles dissociated, and then what will be its degree of dissociation, DOD. If suppose you will take 1 mole of electrolyte, out of this 1 mole, how many number of moles dissociated? Suppose X mole of electrolyte are dissociated. What is the formula? Formula DOD, degree of dissociation. Number of moles dissociated upon total number of moles. Number of moles dissociated X upon total number of moles taken. How much? 1. X upon 1? X. Okay. If you will take 1 by 2 moles of electrolyte, number of moles taken 1 by 2, and the degree of dissociation is X. Right? Then what is the formula? Number of moles dissociated upon total number of moles taken. See, number of moles dissociated means second column, and number of moles taken means first column, means 2 by 1. So X upon 1 by 2, it will be 2X. Okay. If suppose A, consider A is the number of mole. Assume that A is the number of mole. Out of A moles, X moles are dissociated. So what will be degree of dissociation? X by A. If suppose A moles are taken and twice of X moles are dissociated, then what will be degree of dissociation? Twice of X upon A. Got it? Okay. Now, the next point is one more thing. This is the formula to calculate degree of dissociation. Now, you can calculate percentage dissociation also. How can you calculate percentage dissociation? Alpha into 100. If you will be asked to calculate percentage dissociation, what you will do? point is types of acids and types of bases. There are three types of acids and three types of bases for your syllabus. Last year already you have studied types of acids and bases. Okay. First is Arrhenius. In the form of table we can write. See here type. Then second column will be acid and base. And we can discuss example also. Now, first type is Arrhenius. Arrhenius acid, Arrhenius base. Second we will discuss Lewis acid, Lewis base. And third Lowry Bronsted acid and Lowry Bronsted base. In this chapter mainly we are going to deal with Lowry Bronsted acid and Lowry Bronsted base. This chapter is mainly based on Lowry Bronsted acid and Lowry Bronsted base, so this is more important. Now, still we will discuss these two types. What is Arrhenius acid? The substance which gives H plus is a Arrhenius acid, and the substance which gives OH minus is a Arrhenius base. Example of acid, example of base. You can take example of HCl. When HCl dissociates, it gives H plus and Cl minus, right? Okay. So this is the substance which has given H plus. Substance which gives H plus will be Arrhenius acid. Base NaOH, it will give Na plus and OH minus. It has given OH minus, so it will be Arrhenius base. Now, Lewis acid and Lewis base. According to Lewis, the substance which accepts lone pair of electron, the substance which accepts lone pair of electron will be Lewis acid, and the substance which donates lone pair of electron. See, the substance which accepts lone pair of electron, Lewis acid, and the substance which donates lone pair of electron will be Lewis base. For example, we will consider example of acid and example of base. AlCl3 is a Lewis acid because AlCl3 accepts lone pair of electron. Now we will not discuss in detail because mainly we are going to deal with Lowry Bronsted. And NH3, that is ammonia, is a Lewis base because it donates lone pair of electron. NH3 is having nitrogen, nitrogen is having one lone pair, two extra electrons that can be donated, so it will act as a Lewis base. Okay. Now the main point of our interest is Lowry Bronsted acid and Lowry Bronsted base. According according to Lorry-Bronsted, the substance which gives H plus, substance which gives H plus will be Lorry-Bronsted acid, and the substance which accepts H plus will be Lorry-Bronsted base. See, the substance which will give H plus acid, and the substance which accepts H plus will be base, Lorry-Bronsted base. For example, see, acid and base. HCl when dissociates, it gives H plus Cl minus. So it will be acid according to Lorry-Bronsted. Now the base NH3 can accept H plus. So when NH3 accepts H plus, it becomes NH4 plus. It has accepted H plus. See, the substance which accepts H plus will be base. So NH3 has accepted H plus, so it will be Lorry-Bronsted base. Combinedly, this reaction can be written like this: HCl plus NH3. So what it will give? HCl will give H plus. See, HCl will give H plus and Cl, and NH3 is going to accept this H plus. See, total number of ions are 1, 2, 3. First ion is H plus, second ion is Cl minus, and third ion is NH4 plus. How NH4 plus is formed? NH3 has taken this H plus. Means actually this ion is already consumed. This ion is accepted by NH3. So this ion is not available. Only Cl is available. So Cl is available, and second is NH4. And this NH4 plus Cl combine to form NH4Cl, ammonium chloride. So here this is Lorry-Bronsted acid, and this will be Lorry-Bronsted base, because HCl has given H plus and NH3 has accepted H plus. Okay. The last point is dissociation constant. I will write here. See, dissociation constant. Okay. Dissociation constant can be represented by symbol K. Can be calculated by the formula concentration of product upon concentration of reactant. Consider this reaction. HCl gives H plus plus Cl minus. So K for this reaction will be concentration of product. What is product here? H plus and Cl minus. Concentration can be represented by square bracket. So concentration of H plus, concentration of Cl minus upon concentration of reactant. Reactant is HCl. So this is the formula. This is the equation of dissociation constant. Dissociation constant K. Now this K is for HCl. HCl is a acid. So here you can write small k and the suffix. Dissociation constant of the acid is equal to H plus, concentration of H plus into concentration of Cl minus upon concentration of HCl. Got it?